All right, let's talk about identity elements. What do we mean by this? Is another property of binary operations. So identity elements. So basically, if there exists an element E belonging to S, this symbol, this is E belonging. This symbol stands for belonging, or is a member. So let's have an element E. If there exists an element E that belongs to set S, such that A operation E is equals to E operation A is equals to the same A. Okay, they're also telling that if the operation between A and its identity element is commutative, if you swap operands, you get the same A. So if A operation is identity is A, we say for all A belonging to a given set S, then E is called an identity or neutral element. You see, identity element does not change the original elements. So basically, we are saying that E is the symbol for identity elements. Identity, okay, it does not change the operation, the value of the operand. Okay, so it doesn't change the value of A when it operates on it. So E on A in any order, commutativity has to be for it's a commutative operation. A remains A. That's what you're just saying. The operation of identity element on A remains A. Okay, so the identity element is also known as the neutral element, and the symbol is small letter E. Okay, let's look at an example. We have an operation square. Okay, operations can have different shapes, asterisks most times, whatever. In this case, this is a little square. It's defined on the set R of real numbers by, okay, this is the rule, A operation B. Okay, so we have an operation, this is symbol, is defined on the set R of real numbers by, so A operation B. The rule for A operation B is A times B all over 3 for all A, B belonging to a set of real numbers. Remember I told you this symbol that looks like capital letter E stands for belongs to, or is a member of. So for all A, B belonging to set R. Let's get used to this terminologies and symbols, mathematical notations. Find the identity element. So we're told to find the identity element. So basically I'm just going to apply this rule. So let's go. So we have this rule A. So this is the formula for identity elements, commutativity. Okay, so A remains A at the end. So now on the next line you now apply what you are given. So your B is now E, identity element. Okay. All right. So your B, because of see you have A, right? We have A operation B. Now in the formula it says operation E, because of course that's the formula for identity element. This is the formula that helps you to find the identity element. So that's what's been applied here. It's just that the operation might change. Could be AB over 3. Next question could be 2x over y, whatever. So your B is now substituted. You replace your B with E. Okay, so AE over 3. Okay, AB over 3 becomes A over 3, and F must give you A because identity doesn't change. Okay, so just understand that. So let's look at this particular operation. We don't know what this is, but this is a rule. Okay, so this is quite different from multiplication or addition. Okay, although it could include it. So you simplify what we have. So this is the rule. This is the question. So we're applying the rule. So after the first line, you have A operation E equals to AE over 3. That's A times E divided by 3. It must give you A, because the operation of the identity elements on an element doesn't change the element, it remains A. So A times E over 3, 3 can cross over here or multiply both sides by 3. You have A is equals to 3A. Make E the the formula, divide both sides by A. That's AE over A becomes E, 3A over A becomes 3. So E is equals to 3. So the identity element in the set of real numbers under the operation, this operation is 3.